Very good morning to everyone. Today we are going to study about Friedel-Crafts reaction of benzene. It's also a electrophilic substitution reaction of benzene. Now Friedel-Crafts reaction classified into two different categories. First one is alkylation and second one is acylation. But why this type of two different classifications are there? Actually, this classification is created by using two different electrophiles. Means there are two different electrophiles are there which is used for Friedel-Crafts reaction of benzene. So what are the electrophiles? They are, for alkylation it's R dash plus like this, and for acylation along with R is C plus double bonded oxygen, means O, this one. So here R will represent as CH3 plus C2H5 plus, and it's go on like this, means it may be a hydrocarbon. So this same R value is used for both cases, in case of alkylation as well as acylation. Now today we study about only alkylation, that is a part of Friedel-Crafts reaction of benzene. So what will happen? Let's see. Here is our alkylation process. So this is our benzene which will react with a RX compound, that is hydrocarbon, along with some halogen, that is RX compound, and that can be generated our R plus dash electrophile in later, and this will take place in presence of anhydrous AlCl₃. So this one is a obviously Lewis acid and act as a catalyst in this reaction. So after fusion take place, we get our electrophile, means plus R plus, which will attach with our benzene later, and also we get side product like HX. So this is our desirable product, means after completing the Friedel-Crafts of alkylation of benzene, and this is our side product HX. So I just show you a single step reaction without using any proper reactant. Let's go for its mechanism for more understood our topic, that is alkylation, and with proper example. Let's see. So mechanism, first step is generation of electrophile. Our reactant, suppose CH3Cl, which will react with AlCl₃. So fusion will happen, as we know, in between the single bonds of CH3 and Cl, like this. Now we get our electrophile. Another one is nucleophile, and AlCl₃ is a Lewis acid capable for capturing this nucleophile, which will prevent the reversible process of this mechanism. Finally, our electrophile is ready, and it's go for second step, that is attack to the benzene. Okay, understood? Next, second step, that is attack of electrophile. We all know. So here is benzene. Here is also fusion take place in presence of our electrophile, that is CH3 plus, which will go for the attack where electron density become higher. So finally we get like this intermediate. So this is all about our attack of electrophile. Now comes for our final step, that is removal of old electrophile. So this is our intermediate structure we get from our previous step, that is attack of electrophile. In this carbon atom, this having a hydrogen atom which will donate its electron to this carbon atom and leaving the ring itself as a electrophile. Now in the solution we have already get AlCl₃ minus as an intermediate complex which will donate its electron to this hydrogen atom, means electrophile. We get finally HCl, that is our hydrochloric acid. Along with we get AlCl₃, which will remain same as a catalyst, and we also get our desirable product, that is toluene. So finally we complete our Friedel-Crafts alkylation of benzene. So I hope all of you get understood its mechanism perfectly. Let's try some more example with alkylation of benzene. Okay. Now this one is a very important question for this topic. Question number 1. You have to complete the reaction below. So here it is. But I have already explained its mechanism to you. So I just told you what are the desirable products for this reaction, just skipping the mechanism steps. So what are the desirable products for this reaction? So as we know, here it is our reactant. So we just write like there is benzene plus our reactant. So we know there is fusion takes place. After that this bond is break and we get our electrophile and nucleophile. So nucleophile will captured by AlCl₃. Okay, and this electrophile is attached to our benzene and it will attach with this benzene. So our desirable product like this. So here it is our ethylbenzene along with our HCl, and also finally we get AlCl₃, as it is same because it's a catalyst. Understood? Okay. Next, question number 2. Again a incomplete reaction. You have to solve it. So this is your question. So all of you just pause my video, or I just give you 1 minute time to solve this question. Okay, so just do it by your own. Your time will start now. Your time is running. Hurry up. You just find out what is your desirable product. Hurry up. Okay, sorry, time up. I hope all of you done this one easily. So I think your answer is this one, right? So this is I think your desirable product is this one, and also this one. Okay, from this using this reactant. So if your answer is this one, then I need to say you are wrong. Now why? If you see the reactant carefully, here is the position where fusion can take place. Because leaving group is close to this bond. Now here is our electrophile and nucleophile. I think up to this much all of you are right. Now comes for the most interesting part. I told you in your previous semester class that when a carbon having a positive sign on its top, it's a formation of carbocation. Remember it? Okay. So this one is your carbocation. But which carbocation? It's a 1 degree carbocation. Right? Because it's directly attached with only one carbon. Now according to stability, 3 degree is more stable than 2 degree than 1 degree. So if there is a possibility to changing the order of stability from lower stability to gain higher stability, then we must have to do that. So here is a possibility if we are transferring this carbocation from 1 degree to 2 degree. So this carbon is directly attached with this carbon and this carbon. So this carbon is be a 2 degree carbocation if we are transferring this carbocation from this position to this position. So that's mean in this reaction rearrangement of carbocation is required. Now there are different types of rearrangement process for carbocation like hydride shift, methyl shift and phenyl shift. So for this reaction we required 1,2 hydride shift. So our electrophile become like this one. And it's a 2 degree carbocation which is more stable than the previous one, that is from 1 degree. Understood? Now this whole process means this fusion, this rearrangement of carbocation, and this is our electrophile generate. Okay, means generation of electrophile complete. So all these things will be happen in our single step, that is our first step, generation of electrophile. All these things will be happen in our first step. Step number 1, that is generation of electrophile. So our desirable product is this one. So this one will our desirable product and this one is our side product. Okay, so this is our isopropyl benzene and this one is AlCl, that is hydrochloric acid. Okay, understood? So for today's class that is enough. Thank you everyone.